Good evening, everyone, and welcome to another live session for Introduction to Biostatistics, whose course instructor is Professor Shamik Sen from IIT Bombay. I am Prashasti Pandey, PhD scholar and PMRF fellow from Department of Botany, Banaras Hindu University. And as we are going in this another live session, if you have already attended, we solve previous year's assignment questions. We have questions and answers to those, and we will try to solve them. We will try to understand the concept behind those questions. And the idea behind these live sessions is so as to make it easier for you to solve the assignments that are given to you during this coursework. We will not be answering the questions of this year's assignment, but yeah, these sessions will definitely help you solve them. So we will just wait for 5 to 10 minutes for students to join, and then we can start with the session. Okay, so let's begin with our first question. So the first question is the percentage of voters who support candidate X in the population of male voters aged 30 to 35 has an unknown mean P and a standard deviation of sigma equals 5%. It may be useful to campaign managers to know whether the mean of this population is equal to the mean percentage of support for candidate X in the general population of female voters of this age, which is 48%. What is the null hypothesis and alternative hypothesis for this test? Okay, so these live sessions are all mostly based on this concept of hypothesis, which is null hypothesis and alternate hypothesis. So I'll give you 5 minutes and you can try solving this question. After which we will try to understand the concept and also solve the question. Okay. So let us try to understand this question. Okay. So let's first try to understand the basic concept of this question, which is what is a null hypothesis and what is a alternate hypothesis. Okay. So now these when we usually do statistics for any to come to a conclusion for any research, it is usually not possible to get a single value for an entire population or for a large number of samples that we are trying to study. It can be population or it can be any scientific samples. So in that case, we usually use representative figure to address the statistical significance of any conclusion. Okay, so before doing the analysis or before even performing the experiments, we need to hypothesize that what might happen after doing this. So suppose if a company has developed a drug, suppose the medicine XYZ, and the company is claiming that XYZ is able to reduce the some disease. Okay, so the statement that this medicine can reduce the disease is the hypothesis. Okay, or the other hypothesis can be that it cannot solve it. Okay, this medicine cannot reduce the disease. So these two statements are hypothetical statement where it has not been proved yet. To prove this, there are certain sets of experiments and certain results, and then you do statistical analysis on it and find out whether there is a significant difference or significant indifference between them. And that's when you come to a conclusion to it. Okay. So, to give a hypothetical statement, there has to be a hypothesis. Now, there can be two kinds of hypothesis. One is called as null hypothesis, and the other one is called as alternate hypothesis. Okay. So, null hypothesis is usually represented by H naught, and it is a basic assumption in statistics where when you say that there is no effect or there is no difference or no relationship between the variables, that statement will be called as null hypothesis. So, in case of the medicine that we're talking, if you take the example of the medicine and a disease, and if we say that this medicine does not affect this disease, or this medicine does not play any role in affecting the disease, then in that case, it will be called as a null hypothesis. Okay, so now null hypothesis usually acts as the starting point or the default statement when any kind of test is supposed to be done by any kind of researcher or any before beginning any research, the first statement that is given is the null hypothesis, and that first statement is always that this is not happening, or there is no effect to this, or there is no difference, or there is no relationship. Okay, so that hypothesis is called as null hypothesis. We've already taken an example for the medicine. You can take another example of a fertilizer on plant growth. So if you are taking if you develop a new fertilizer and you are checking whether it has an effect on the plant growth or not, then in that case, your null hypothesis will be that the fertilizer has no effect on the plant growth. That means no matter what you do with the fertilizer, you increase it, you decrease it, the plant's growth will is totally independent of that fertilizer that you are putting. Okay. So that will be your null hypothesis. Now the second one is alternative hypothesis. For alternative hypothesis is also written as either H1 or it is also written as HA. The null hypothesis is represented by H naught. Okay. So now the opposite statement of your null hypothesis will be the alternative hypothesis. So your alternative hypothesis statement will always contradict the null hypothesis. If you're saying that the fertilizer has no effect on the plant growth, and if that is your null hypothesis, then in that case, your alternative hypothesis is that the fertilizer is affecting the plant growth, or it is causing some effect, or some difference, or some relationship, but there has to be some effect between the two, and that statement is called as an alternative hypothesis. Now, alternative hypothesis can be either two-tailed hypothesis or one-tailed hypothesis. If if it cannot be proved that what kind of effect that a particular thing is showing, or there is the particular relationship between two things, in that case it is two-tailed. So suppose you have just proved that fertilizer is affecting the plant growth, but you don't know whether that effect is positive or it is negative. So it could be that adding the fertilizer is reducing the plant growth, or it could be that adding the fertilizer is increasing the plant growth. So when you don't exactly know that what kind of relationship is, whether it is positive or negative, in that case the relationship is a two-tailed alternative hypothesis. On the other hand, if you know what exact effect it is showing, that if whether adding fertilizer is increasing the plant growth or it is decreasing the plant growth, based on that, it can be either in positive direction or a negative direction, but there is some direction to it. So in that case, your alternative hypothesis is a one-tailed hypothesis. Okay, so in short, if you take this example, if you say the statement that fertilizer has no effect on the plant growth, that will be your null hypothesis. And if you say that fertilizer does have effect on plant growth, that will be your alternate hypothesis. And this does effect will determine whether it is a two-tail or a one-tail, whether it does you know exactly it is having a positive or a negative effect, or you don't know what exact effect it is showing. So I hope the basic concept of the hypothesis is clear with this. And now coming back to our question, our null hypothesis with that statement was that the mean support among male voters aged 30 to 35% equals to 48%. So your p value is 0.48. That is your null hypothesis. And your alternate hypothesis is that this is not. Your p alternate hypothesis will be your p is not equal to 0.48. The thing that we are trying to find out, the opposite of that will always be null hypothesis. Okay, so in that case, we are trying to find out whether it is not. So that will be the alternate hypothesis, and the null hypothesis is that it is p value is equal to 0.4. Okay, so now based on this, your option two will be correct. Sorry, I'm sorry, your option three will be correct, where your null hypothesis is that p is equal to 0.48, and your alternate hypothesis is that p is not equal to 0.48. So I hope this question was clear, and we can move on to next question. Okay, so your next question is a candidate conducts a statistical test for two-tail hypothesis. So I hope this word now becomes more clear that what two-tail hypothesis is. So a candidate conducts a statistical test for two-tail hypothesis to obtain a mean value of a random variable y where H naught, your H naught is the null hypothesis. So your null hypothesis is mu equals to mu naught versus your alternate hypothesis is that mu is not equal to mu naught. Now the candidate performs and obtains a test statistic of 2.2. Given a 5% significance level, determine the p-value. Okay, and your options are given below that p value is 2.78%. So you reject the hypothesis. P value is 1.78%. You accept the hypothesis. P value is 1.78 and reject the hypothesis. And p value is 2.78 and accept the hypothesis. So let's take 2 minutes and try solving this question. I will write whatever the values are given so it becomes easier. Okay, so let us start solving this question. Okay, all right. So these are the values that were given that I already wrote that your null hypothesis is that mu equals to mu naught and your alternative hypothesis is mu is not equals to mu naught. The test statistic value z equals to 2.2 and because nothing else is specified, we are assuming that the distribution is normal distribution, and that is why the z statistic is given. So the distribution is standard normal distribution, and the values that we will be using to solve this question will be a standard normal distribution table values specifically for z test. Now, to solve this question, we will go step by step. So step one will be to find the one-tailed probability. Now, to find this, your z statistic value is 2.2. Okay, so now you need to find this particular value from the z table that I mentioned earlier. That there is a specific table which you can get, and the values for that tables are very specific. So if you look at the value for z, when the z statistic is 2.2, the value from the table is 0.9861. So this is something you can get it directly from the table also, or you can use a z statistic calculator to obtain this value. Now, so now if you try to calculate this value that when z is more than 2.2, it will be 1 minus this value which is 0.9861 and you get the result of 0.0139. Now, when you know this, so this is your one tail probability. Now you need to convert it to two tail probability for the p-value. Now to calculate the p-value for two tail test, you need to multiply this, the value that we have previously obtained, which was 0.0139, and you multiply it by 2, and then you get the answer of 0.0278. So the p-value is approximately 0.028. So we just converted this last digit, and we can get the value of 0.028. Now the question was asked that at significance level of 5%. So your significance level is represented by alpha, and alpha value at 0.055 should be calculated. Now, at significance level, we say that P should be less than 0.05, and in that case, we will be rejecting the null hypothesis. Okay. So, when we talk about significance level, your P value will determine whether we will accept the null hypothesis or reject the null hypothesis. So, when we test any statistic, we usually either accept or reject the null hypothesis. Now, if your p value would have been greater than 0.05, in that case, the null hypothesis would have been accepted. But your p value is less than 0.05 because it is 0.028, which is less than 0.05. In that case, the null hypothesis will be rejected. So, the answer to this question would be that p-value is 2.78 per. Okay. So we calculated the value as 0.028, and if you convert this into percentage, your answer will be this 2.78%. Okay. How did it come to 2.78%? Because this value is taken to convert. It is 0.0278 into 100 converted into percentage, and that will come to 2.78%. Okay, so that is our answer, 2.78%, and the hypothesis will be rejected. Okay. So to this question, your option A will be correct. Okay. So I hope this is clear. So to solve these kinds of questions, we will have to use okay. So you need to know the values for Z statistic, for which we need to know the standard distribution table for Z statistics, and it's very simple to calculate this. Okay. So now let's move on to our next question. This is a theoretical question, and it should be easy to solve. So what is a p-value? Your options are that it is a probability of the alternate hypothesis being true. It is the probability that a test statistic is at least as extreme as specified value of the test statistic, given that null hypothesis is true. It is the probability of the null hypothesis being true and the probability of null hypothesis being false. If anyone of you knows the answer, you can write it in the chat box or you can tell the answer. Otherwise, you can proceed to solve this. Okay, so this is a simple question. We can solve this question. Uh, the concept of p-value. So in statistics, the p-value is the probability of observing a test statistic. Okay, so when you observe a test statistic, it can be as extreme as the one we have got. It is basically when you understand, when you try to say the statements by using statistic, and when you don't know the exact uh, answer to that, we say that the probability of happening this. Okay. So assuming the null hypothesis true is the probability of getting the correct answer to the null hypothesis. Okay. So in that case, when you try to, I mean, if I explain that in simpler words, it tells you that how much is the probability of your null hypothesis being correct. So the smaller the p-value will be, the means that your result is unlikely under null hypothesis. So you will have the evidence to reject the null hypothesis. If you remember the previous question, in that case also our p-value was 0.028, in which case we rejected the null hypothesis. Okay, so if you say that your alpha value is 5%, which is 0.05. Okay. So if the p-value, if while using statistic, your p-value is coming at 0.05%, in that case, we will reject the null hypothesis. Okay. So if your null hypothesis statement is that there is no relation between these two events happening, then in that case, if your p-value is less than your alpha value, that your null hypothesis or this statement that there is no relation between these two will get rejected, and your alternate hypothesis will get accepted, which is that there is a relation between these two events happening. If I try using an example to explain this, that the relation between using a fertilizer on the plant growth, so your null hypothesis is that there is no relation between the use of fertilizer and the plant growth, and the alternative statement was that there is a relation between use of fertilizer and plant growth. So now if you're getting a p-value of less than 0.05, your null hypothesis is rejected. That means that there is a relation between using fertilizer and a plant growth. Now, on the other hand, suppose if your p-value is coming as 0.7, 0.72. Okay, so in that case, your p-value is more than 0.05. In this case, your null hypothesis will get accepted. Okay, so if your null hypothesis is getting accepted, which in this case, the example that we have taken, that means that use of plant fertilizer has no relation on plant growth. Okay, so there is, so when we are doing experiments, and if our p value is larger than the accepted value, the alpha value, that means that we do not have enough evidence to reject the null hypothesis. And whatever the null hypothesis is, that statement is rejected and the alternate hypothesis accepted in case of larger p values. So smaller p values will represent that your null hypothesis is rejected. So according to this question, the answer will be that it is the probability that a test statistic is at least as extreme as specified value of the test statistic, given that the null hypothesis is true. Okay. So our next question is supposed to be solved. The null hypothesis will be rejected, where your null hypothesis is that mu equals to 14, and alternate hypothesis is mu is greater than 14, and alpha is 0.01. 0.01, that means acceptance is of 1%. Okay. If the z value is greater than. Okay, I'll give you 2 minutes. You can try solving this question. Okay, so let's try solving this question. Okay, so now our null hypothesis is that mu equals to 14, and our alternate hypothesis is that mu is greater than 40, and the alpha is 0.01, which is 1%. Yeah. So now for critical for right tail test, when your alpha value is 0.01, we again need the z value for the upper probability. So from the table, when you look up to the value of z under 0.01, it is 2.33. Okay, so this value is from the table. Now, if our z value is greater than 2.33, in that case only we will be rejecting uh, the null hypothesis. Okay, so this was exactly the question. The question was that the null hypothesis will be rejected if the z square value is greater than. So your option D is correct. Yes, one of you answered it. So yes, option D is correct in this case. So to answer this question, we just need to know the z value in case of alpha 0.01 from the table, and you can solve these questions, these kind of questions. Okay. So this is a theoretical question. What is type 1 and type 2 error? Your options are H naught is rejected when it is true in both cases. H naught is rejected when true, and H naught is accepted when false, respectively. H naught is accepted when false, and H naught is accepted when false, respectively. And H naught is accepted when false, and H naught is rejected when true, respectively. If anyone knows the answer, you can write it in the chat box. Okay. So it's a very simple concept. Let's just try to understand. So there are two types of errors in statistics. One is type 1 error, which is also called as the alpha error. So in case of type 1 error, when you reject the null hypothesis, even though it is actually true, and that kind of error in statistics is called as type 1 error. Okay, so in case if in normal language, you can say that it's kind of a false alarm. So if you take the same example of the medicine, so when you are concluding that the new medicine works better than the old one, when actually that is not the case. So of course, we are saying that we reject the null hypothesis. So what our null hypothesis would have been that the new medicine is not better than the old one, but we rejected it. So that means that we are saying that the new medicine works better than the old one, but in actual case, that is not true. Okay, so these kinds of errors, when you reject the null hypothesis, when that is not actually true, is a type 1 error. And uh, in that case, the kind of errors that come is falls under the type 1 error or the alpha errors. The other type of error is type 2 error, also called as the beta error. So now in this case, when you fail to reject the null hypothesis, when in actually case your alternative hypothesis was true, that means that your null hypothesis is accepted, but it is not true, right? So in that case, the error arising from this is called as a type 2 error. So if we take the medicine example again, that means that if we have concluded that the medicine does not work in reality, but the truth is that it actually works. So, in this case, it means that we have accepted the null hypothesis, but that was not the case. The alternative hypothesis was true, and therefore, the error from this is your type 2 error or the beta error. So now, the correct answer to this question is that your null hypothesis is rejected when it is true, is type 1 error, and null hypothesis is accepted when it's false, is the type 2 error. So, your option B is correct. Okay. So, our next question is a t-test is done when null hypothesis states that mu equals to 90.69 and x bar is 78.24, s equals to 13.3, and n equals to 10. The question is, what is standard variable? The options are 1.41, 3.18, 2.96, and 4.64. Okay, so Murli, your question is that whether you need to bring a table or will they provide it in exam hall? Um, I'm sorry, but I can't answer you this question exactly because we don't conduct the exams. I'm just a TA and I'm also a student, so I'm sorry, I won't be able to answer this question. But I can get this information from someone, and I may be able to answer this question in the next live session once I get this information. But for now, even I am unsure that how this works. But I'm sure that they will give you these instructions under your admit cards before the exam. But I can get it checked. If I get this information, I will inform you in the next live session, or maybe you can ask this question in discussion forum, and definitely somebody will answer that. Okay. So let's try to solve this question. So this is so in this question we are saying that a t-test was done. So we need to the formula for t-test is x bar minus mu naught upon uh, s by square root of n. So in this formula, the values that are given, which is your x bar, which is the mean, sample mean, is given is a 78.24. Your hypothesized mean, which is mu naught, is given as 90.69. Standard deviation is 13.3, and the n value, that is your sample size, is 10. Okay, so we have all this value. Now the question is asking what is the standard variable. So your standard variable is represented by z. Okay. Okay. So now to calculate this, so in this case, we need to calculate this value, which is s by square root of n. And now, if you calculate, so the standard error will be your s upon square root of n is it's nothing but standard error. So your s value is 13.30, and your square root of n is square root of 10. Okay, and square root of 10 is approximately 3.1, which is given here 3.1623. And if you calculate this, 13.30 divided by 3.1623, you get an approximate value of 4.207. Okay, so this is your standard error value from the values that have been given in the question. Now, with this, now we need to compute the numerator. So your numerator is the difference between the mean values that is calculated and the mean value that is hypothesized. So the calculated mean value was 78.24 and the hypothesized mean value was 90.69, which comes to the difference of minus 12.54. Now, if you compute the t statistic, you just need to divide this, which is minus 12.45 divided by 4.207. 4.207 was a standard error that we calculated, which was s upon square root of n. Okay, so if you calculate this, you get the value of minus 2.96. Now, this is the t statistic. So now that was exactly the question that to find the standard variable. So your answer at option C would be correct in this case, 2.96, which we calculated right here. And that is the answer. Okay. So I hope this question was clear. And let's move on to our next question. For a test, the null hypothesis, which is H naught is mu equals to 10, and the alternate hypothesis of HA is mu is less than 10 at an alpha of 0.05 level. The sample mean is 9.75 and the sample standard deviation is 2. Where sample size n equals to 100, what is the correct conclusion? Whether alpha value must be lower, accept the null hypothesis, data is inconclusive, or reject the null hypothesis. You need to calculate the p-value for this and then determine whether to accept or reject the null hypothesis or the way data is inconclusive, or the alpha value, which is 0.05, should have been lower. Okay, so let's try saving this. So we are testing that our null hypothesis states that the hypothesized mean is 10 versus the hypothesized mean is less than 10, which is our alternate hypothesis. The alpha is given as 0.05. The mean value is 9.75. The calculated mean value is 9.75. Standard deviation is 2 and n equals to 100. Now we need to compute the Z statistic again, which is x bar minus mu naught upon s upon s by square root of n. Square root of n is your standard error. So now standard error will be uh, s value was 2, n is 100. So 2 by 10, which is equals to 0.2 is the standard error. Now to calculate your x bar minus mu naught, which is calculated mean minus hypothesized mean, calculated mean was 9.75 minus the hypothesized mean is 10, difference is minus 0.25. Okay. So now the statistic will be minus 0.25 upon 0.2, which is the standard error. The answer is minus 1.25. Okay. So now, so this is from the table again that alpha at 0.05 value should be minus 1.645, and the value that we have got is minus 1.25. Okay, so minus 1.25 is more than minus 1.645, which should have been the value of z at alpha equals to 0.05. Now, since this value is greater than the value, then in that case, we fail to reject the null hypothesis. So, if your null hypothesis, if you fail to reject the null hypothesis, that essentially translates to that at 5% significance level, there is not enough evidence to conclude that uh, mu is less than 10. So in that case, the answer will be to accept the null hypothesis. Okay. If there was any conclusion at this confusion at this point, the answer was that we failed to reject the null hypothesis. That means that S naught will be accepted. Okay. And in this case, the H naught was mu equals to 10. So it will be accepted. So the answer B is correct, that accept the null hypothesis. Okay. If here the answer would have been anything which would have been less than minus 1.645, then in that case the null hypothesis would be rejected. Okay. Okay. So our last question for this session is, given the mean and standard deviation of cell migration distances for a set of subjects before drug treatment, where mean value is 4.9 micrometer, standard deviation is 1 micrometer, and the same subjects after drug treatment, the mean is 6.5 and standard deviation is 1.2 micrometer. Is there a significant difference in cell migration within the same subjects before and after the treatment? Your options are independent samples t-test, paired sample t-test. T-tests are not suitable for this case, and one sample t-test. The question asks that for this kind of result, what kind of test should be can be used? So let's solve this question. So our set hypothesis was that null hypothesis states that the mean difference in migration is zero, and so from the question, we are talking about the cell migration difference. Okay, so we stated that null hypothesis states that the mean difference in migration between the two things, which is the effect of treatment and the control condition. So this mean difference is zero. That means there is no effect. And the alternative hypothesis state that the mean difference is not zero, which is that there is an effect. So now, the information that was given is before treatment, the mean value is 4.9 micrometer and standard deviation of 1 mu m. And after treatment, the migration mean is 6.5 mu m with the standard deviation of 1.2 mu m. Now, because these things have same subject, that means the test needs the mean of paired differences and the standard deviation of those differences. Okay, not just separate standard deviations. So right now we have two separate standard deviations, but instead we need a standard deviation of the uh, of those differences. Okay. But in the question, we have the values given of group means and the standard deviation separately. That means that there is no pair difference statistic given in the question. Now, without the actual subject level data or the standard deviation of differences, we cannot directly compute the paired t-test. Okay, so you do a paired t-test when you need to find out the differences or when there is an assumption that one variable is independent variable and the other variable is the as a dependent variable. Okay, in that case, we compute the pair t statistic. But without the subject level data and without the standard deviation of the differences between these two, we cannot compute the pair t test. So now, if these two samples are treated as two independent samples, I told earlier that while using paired t-test, there has to be one independent and one dependent variable. But there is no statistic given in the question which we can use in this case that there is one independent and one independent variable. So now we will treat these two samples as two independent samples. Now, if we roughly assume that the before treatment and the after treatment variables are independent, in that case, to calculate the t statistic, we need x1 difference, which is mean of x1 minus mean of x2 upon square root of standard deviation of 1 upon n plus square root of standard deviation of 2 upon n. But now we still need a sample size, which is not given in the question. Okay, because the question only states the value of the mean and the standard deviation of both 1 and 2 and standard deviation of 1 and standard deviation of 2. So N1 and N2 are still missing to calculate the t statistic. So now to properly conduct any significance test within the same subjects, we either need raw pair data or we need the mean of the difference or the standard deviation of the differences, which we don't have. Now, now what we have is only group means and the standard deviation. So the best way we can do it is to calculate the mean differences from this value. So one value was 6.5 and the other one was 4.9, which comes to 1.6 micrometer, which is the differences between the two mean values that was given. But so now since the standard deviations are less than one, that was given in the question, this is likely a meaningful change, okay, because the deviation is very less. But statistical significance cannot be confirmed without the sample size or the standard deviation of the differences, which both values we don't have from the question. So, therefore, the answer to this question will be that there appears to be an increase in the migration distance because the value comes in plus 1.6 micrometer. Okay. Difference was 6.5 minus 4.9 and the value was plus 1.6. That means there is a increase. Okay, if this would have been minus 1.6, that means the migration would have been decreased after the treatment. This is before treatment, this is after treatment. So there is an increase in the migration. However, to test if this difference is statistically significant with pair t-test, we need sample size and the standard deviation of the paired differences. That is why to the answer to this question will be that this can be solved by paired sample t-test. Okay, so answer will be B. Answer to this question will be option B. Okay, so by calculating a paired sample t-test, we can say that there is whether there is a significant difference in the cell migration within the same subject before and after the treatment. Okay. So I hope these questions were clear, and we have another live session next week, same day and same time. And if there is anything else that you want to discuss or you want to ask something, you can ask me. Otherwise, we will end with the session.